Today what we're going to look at is we're going to look at evaluating limits using direct substitution. First thing I'm going to tell you when you are evaluating a limit, always try this first. Always try direct substitution first. If it works out, you don't have to go anywhere else. So, on example 1, I'm going to ask you for the limit as x approaches 2 of 4x squared plus 3. Now, I always have to write that limit part, but once I've evaluated my limit, which is what I'm about to do, I no longer write my limit. So now I'm going to say 4 times 2 squared plus 3. Well, 2 squared is 4 times 4 is 16, so plus 3. 16 plus 3 is 19. That is my limit. The limit as x approaches 2 is 19. Okay, now remember that notation we talked about yesterday. You have to always use that notation. Or you might see something like this. Example 2. The limit as x approaches 1 of x squared plus x plus 2 over x plus 1. Now, first thing I'm going to do, plug in 1. 1 squared plus 1 plus 2 over 1 plus 1. 1 squared is 1, plus 1 is 2, plus 2 is 4, all over 1 plus 1, which is 2. So the limit as x approaches 1 equals 2. Couple more examples. This actually is a very short, quick lesson. Alright, example 3. The limit as x approaches 0 of the square root of x squared plus 4. Alright, well let's plug in 0. The square root of 0 squared plus 4, just the square root of 4, which in this case is 2. So the limit as x approaches 0 is 2. Okay, let's do one more. Example 4. The cube root of 2x squared minus 10. Oops, I forgot. Okay, the limit as x approaches 3 of the cube root 2x squared minus 10. Okay, so we're going to plug in 3. Cube root of 2 times 3 squared minus 10. Well, 3 squared is 9 times 2 is 18. So the cube root of 18 minus 10. So 18 minus 10 is the cube root of 8. Well, 8 times what times what? What times what times what is 8? Well, that is 2. So the limit as x approaches 3 is equal to 2. Okay. Now moving on. I could also do this with some trig problems, okay? Remember I told you a unit circle was very important? This is about to show you why. Okay, so the limit, let's call this example 5. The limit as x approaches 0 of tan x. All right. Well, I can stick in the limit. I can stick in 0. So tan of 0, well, that's 0. But for those of you that don't remember, tan is equivalent to sine over cosine, right? So that means it's also equivalent to the tan of 0 is equivalent to sine of 0 over 0. Sine of 0 is 0. Cosine of 0 is 1, which is just 1. So the limit as x approaches 0 of tan x is 1. Now, example 6. The limit as x approaches pi of x cosine x. So x times the cosine of x. So what I'm going to do here is I'm going to plug in pi for x. So now we're going to find pi times the cosine of pi. So what's the cosine of pi? Negative 1, right? So now I have pi times negative 1. Negative 1 times pi is negative pi. That is your answer. Now let's do one very last one, all right? Call it example 7. I think I have enough room here to stick it on. The limit as x approaches 0 of sine squared x. All right, well, the first thing I'm going to do is I'm actually going to rewrite that sine squared x to make it look more friendly. So let's do the limit as x approaches 0 of sine x squared. Okay, now let's plug in 0. Sine of 0 squared. Well, sine of 0 is just 0. 0 squared is 0. So 0 literally is my answer. Okay, that is how you evaluate limits using direct substitution.